When you take the derivative of rational functions, or when you have fractions, you need to use something called the quotient rule. Just like we had earlier, the product rule, you have a quotient rule when you have a fraction. You can't just take the derivative of this, and then divide, be done. It doesn't work like that, sorry. It's not that easy. Shucks. So here's the quotient rule. U is the top, V is the bottom. And what you do is, just like product rule, do you see how you derive the first, or I call it the top, the numerator, leave the bottom, a minus, not a plus this time, product rule has a plus there, and I leave the top, derive the bottom, and then I take the bottom, square it. This right here will give me the derivative of any fraction, and it's called the quotient rule. Very powerful, very useful. You'll see this a lot. Sometimes you actually see the quotient rule with product rules involved, so you might have to start mixing these all up. So that can get a little ugly too. But it's a very useful and used a lot procedure. Just remember the minus, and product has a plus, and with the quotient rule, you also have the bottom squared. So let's show you how it works. All right, for this particular problem, all right, let's do the derivative. So f prime x is going to be equal to, well, u prime, or the derivative of the top. So what's the derivative of this top going to be? Negative 2x. Hopefully you can see that. Okay. Then I leave v, so leave the bottom. The bottom is tangent x. Alrighty. And then I put a minus. Okay. And then I have u, which is just the top, so leave the top. 4 minus x squared. And then I derive the bottom. What's the derivative of tangent x? Isn't that secant squared x, or secant x squared? All right, so we did the top. Now we got to take v squared, or the bottom squared. So we basically do, okay, tangent x squared. All right, we got it. That is our derivative. Now, could we simplify this? Well, yeah, I mean, I can't really bring this together. I could distribute the secant squared of both of these. I could possibly divide both by tangent squared x. But there's so many different ways to simplify rational functions. I'm actually not going to simplify this one. All right, we're just going to let this one be the answer. All right, so let's let it be. Now, what you're going to run into is a lot of times you want to distribute the tops, get it all nice and neat on top, see if there's a GCF that maybe could come out and cancel with the bottom somehow. It is usually important to simplify these. But when I look at this, there isn't going to be any good simplification that needs to be done on this particular problem. This is the basic derivative. All right. Now, what you're going to find out with calculus is the calculus, these quotient rules aren't that bad. It's the simplifying if you have to that can be very annoying. All the algebraic simplification. This one does not have it. All right, this one has a very simple one because I can tell there's not much to happen when you simplify. And with practice, you start learning. So make sure when you do homework problems, you look at the answers, you try to get the answers they ask for, because there's a whole bunch of different ways to simplify problems. All right, got another fraction here. What are we going to do? Well, we could use quotient rule, but there's something a little bit easier. Can you see it? Could I just change this into a polynomial and not even use quotient rule? Take a look, watch what happens. I'm going to rewrite this. Can I rewrite this as 6x to the third over 3x squared? Can I divide 3x squared by both those? Divide both by 3x squared. Now watch what happens. When I do that, watch this, it's pretty cool. 6 over 3 is 2. X cubed over x squared is x. Right? 12 divided by 3 is 4. And think of a 1 there. What's 1 x first over x squared? What's 1 minus 2? Is that negative 1? So isn't that x to the negative first? All right. can I simply derive this, take the derivative of this now? Isn't that a simple polynomial? Very easy to take the derivative of? Yeah. So what's this going to be? What's the derivative of this right here? Again, we're focusing in right here. The derivative of 2x is 2. All right, because the derivative of x is 1. 2 times 1 is 2. Okay, be careful here. Take the negative 1 times a negative 4 becomes a positive 4. X. And what's negative 1 minus 1? Be careful, be careful, be careful. It's negative 2. A negative 1 minus 1 is negative 2. And that is the derivative. What I end up with then is g prime x is equal to 2 plus 4 over x squared. All right. Now there is the ability to simplify this, and with derivatives, let's go with simplifying this. Let's basically get the common denominator. Again, this could be a perfectly fine answer, but I want to get a common denominator. So do you notice I could technically multiply top and bottom by x squared? All right, multiply top and bottom by x squared. Maybe put that over 1 and multiply top and bottom by x squared. What you'll notice here is I get 2x squared over x squared plus 4 over x squared. What do you see happening? My answer is 2x squared plus 4 over x squared. That is a very good answer. All right, again, what was in green before I multiplied top and bottom by x squared is reasonable, but what you're going to find out in future calculus, you always kind of want to get a fraction with one denominator, because it becomes very important with some future steps. So that is a lot better answer you want to get to. All right. Now, could I have done quotient rule? Could I have derived the top, leave the bottom, leave the top, derive the bottom, subtract them, and then square the bottom, and then simplify down to this? Yeah, but can you imagine that maybe being a little bit more complicated? I probably wouldn't do it. I like this. I like making it a polynomial. I tell my students all the time, let's do this. Let's get used to this procedure, because if you do quotient rule, it can be a lot uglier and cause a lot more mistakes. But you could choose your method. So here's the thing. If you could ever change a quotient into something like this, please do it. I think it'd be a lot easier for you. Yes, you might have some simplification to do in the end, but the derivative is real simple. All right. But here, I mean, you could divide by tangent x, both those, but then you have two quotients. It's not going to help you. It's not going to simplify. Now you have two quotients, it makes it even longer and uglier. So you got to start learning, when do I simplify and when do I simply do the quotient rule? You're going to learn that with practice. It's just practice. Sorry, I don't have a quick answer for you on that one. So good luck with the quotient rule. Be careful with it. Make the connection between it and product rule. It's just like product rule on top, except it's a minus with the little denominator squared on the bottom. So it's really good to make the connection with it and product rule. They're very similar.